Now, observe STB port selection based on port cost. In this section, we're going to be manipulating the port cost, and then we will see which will manipulate the block port to become designated ports by changing the port cost. Now locate the switch with the block port. We have a switch S1, S2, and S3, and locate switch which has the block port. Go to the S1, and we go enable. Now show spanning tree tab completions, and S1 is the this bridge is the root. That means they have it has a both of the ports are designated, so there is no block port here. Now let's go to the switch 2 and show spanning tree tab completions, and in switch 2 we see there's a block port here, fast Ethernet 0/4 has a path cost of 19, and it has an alternate port, and it is in block state. And now let's compare this with the switch 3 show spanning tree. Go to the switch 3, enable show span tab completions, and switch 3 has one is a root port, other one is designated ports, and switch S2 has one block port. Now let's compare it. The reason they have both cost is 19 and block port cost is 19. Let's go to the topology, S1 and S2. Now you see that switch S2 fast Ethernet 0/2. This one is fast Ethernet. This is the root port, and fast Ethernet 0/4. This is the one that has been blocked, and its cost is 19. And now if you go, let's go to switch 3. And in the switch 3 we see fast Ethernet 0/4 as the forward state, fast Ethernet 2 is a forward state. So why this port has been blocked? Because it has a higher MAC address. We can see that S2 its MAC address is 00E0, and S3 MAC address is 00D0. 00E0 is in hexadecimal higher than 00D0, and this is why we see that it has a alternate port, and that is in block state. Now, so we have located the block port. Now change the port cost. In addition to the block port, the only other active ports on the switch is the port is designated as the root port. See that it is a block port, and the other one is a root port, and it is in forward states. Now lower the cost of this root port to 18. Now let's go to this one. config d. Now spanning tree cost 18. Okay, the packet tracer doesn't, let me see, spanning tree. So actually packet tracer does not support the spanning tree and cost command. However, we can see here in the PDF lab that we have changed the after in packet tracer in this lab PDF lab, the switch one has been designated as a the switch one has the block port now, and that's an interface fast Ethernet 0/2. We use the command spanning tree cost 18, and then now we go again show spanning tree. We see that it has been designated as a fast Ethernet 0 fast Ethernet 4 now has been in a designated port instead of alternate. Now this is designated, this is no more an block state. You can see previously fast Ethernet path 0/4 was blocked state of switch 1, but now after they reduces the port cost to 18 from 19, it has changed to um, designated state. It is no longer a blocked port. It is a designated port. It's no longer a block port. Now, why did spanning tree change the previously blocked port to a designated port? And spanning tree changed the previously blocked port to a designated port and block the port that was designated port on the other switch. Now we type show spanning tree on switch 3. You see previously it was a designated port and it became a block port now. So once we have changed the port cost, it has a reversed action. Once we have changed the port cost from 19 to 18, it has reversed the status of the port. STP looks at path cost first. The port with lower path cost will always be preferred over port with higher path cost. Now we remove the remove port cost and change it again. We went to the interface fast Ethernet 0/2 and then we change the port cost towards um, root bridge to no spanning tree cost 18, and then reissue the show spanning tree command to verify STP has reset the port on the root switch back to the originating port setting. So after we have issued no spanning tree cost 18, it takes approximately 30 seconds for STP to complete the port transmission process. So activate the activate port fast Ethernet 0/1 and on all switches, and then we show spanning tree command. We have we will see that now observe STP port selection based on priority. Activate port fast Ethernet 01 and fast Ethernet 03 all switches. We only activated previously port fast Ethernet 02 and fast Ethernet 04 on all switches. Now we're going to be activating fast Ethernet 01 and fast Ethernet 03 on all switches. We go to the switch 1, enable config T, interface range FA 0/1, FA 0/3, and then no shut. Now we go to the switch 2, enable config T, interface range fast Ethernet 0/1, fast Ethernet 0/3, no shut, and now we go to the switch 3, enable config T, interface range fast Ethernet 0/1, fast Ethernet 0/3, no shutdown. Now wait 30 seconds for STP to complete the port transmission process, and then issue the show spanning tree command on the non-root switches. Observe that the port has moved to lower number port link to the root switch and blocked the previous root port. So we're going to be issuing show spanning tree to the non-root switch. So and show spanning tree. So switch 2 has a root port and it's in forward state, and this is not a root bridge. And then switch 1, and show spanning tree. This is a root bridge, so we don't need this switch 1. We go to the switch 3 and show spanning tree. So these are the two switches that um, we need. You see this one has this one has three blocked port. Fast Ethernet 0 is the root port, um, and it's in the forwarding stage. And this one is Fast Ethernet 0, 3 has a root port in its forward stage, and this is a block port. This is a it has one block port, and this is a three block port. So what port did STP select as the root port on each non-root switch? Um, this is a non-root switch, and the root port is Fast Ethernet 0/3. So S3 Fast Ethernet 0/3. Fast Ethernet 0/4. So this one has become the root port for S3. So this one is the root port for the S3. S3. So 03 has become the root port. And then an S2 Fast Ethernet 01 has become the root port. S201. S2 so 01 become the root port for S2. And now why did STP select this port as the root port on these switches? 2 and 3. So why did STP select this port as the root port? This is the root port. The default port value on a port is 128. STP use the port number to break the ties. So this one default value 128 and the port number is 3. This one default value 128 and port number is 1. And they use this port number to break the tie. It is selected the lower port number as the root port and block the higher number port with a redundant path to the root bridge. So now why did STP why did STB select this port as the root port on each of this switch? Um, on the switch 3, STP has selected Fast Ethernet 03 as the root port. 3, this is the Fast Ethernet 03, and according to the root port was supposed to be the port that is close to the root bridge. So this port, Fast Ethernet 03, is close to the root bridge, and this port, Fast Ethernet 04, is close to the root bridge. So out of this both port, STP has selected Fast Ethernet 03 because they both have a default priority 128. However, number 4 is higher than number 3. This is why number 3 was chosen to be the root bridge. And let's go to the switch 2. Switch 2, if 0/1 has chosen to become the root bridge. This is the root bridge. If 0/2 could have been the root bridge too, because these both ports are close to the root bridge. However, since Fast Ethernet, and they both have the same default priority value of 128. However, Fast Ethernet 0 is lower port number than Fast Ethernet 02. This is why Fast Ethernet 0/1 has been chosen to become the root port. Now the reflection questions. After root bridge has been selected, what is the first value STP uses to determine port selections? The answer is the path cost. STP select the path with the lower accumulated cost. And now question number 2. If the first value is equal on the two ports, what is the next value that STP uses to determine port selection? The answer is bridge ID or BID, by selecting the lower value. And now the third questions. If both values are equal on the two ports, what is the next, if both values of BID are equal on the two ports, what is the next value that STP uses to determine port selections? The answer is an aggregated aggregations of port priority and the port number. The lower value is preferred. First, you have here a MAC address, and then you have a bridge priority 30 to 769, and then you have a port priority, which is 128.3. So if both values are equal on the two ports, what is the next value that STP uses to determine port selection? So the answer is the aggregations of port priority and port numbers. So in this case, Fast Ethernet 0/1 which is aggregated port priority is 128.2, and Fast Ethernet 0/1, which is aggregated port priority of 128.1. So aggregated port priority for fast Ethernet 0/1 is 128.1, which is lower than aggregated port priority fast Ethernet 128.2. This is why fast Ethernet 1 has become the root bridge.